Can you tell me where we had stopped last class?
They had not attended last class, ma'am, because there was a function in our college.
Okay, okay. No, last to last class, ma'am. First class. Because last class, it did not happen last week. There was no class before that. I'll just play the slides. We can just go through. We have completed this, right? Concentration terms. How many problems we have solved? Last problem?
Osmosis. Osmotic pressure. Osmotic pressure.
This finished?
ppm. ಹೇಳಮ್ಮ ಏನ್ ತರ್ಕೊಂಡಿದ್ರ parts per million ಆಗಿತ್ತು ಮ್ಯಾಮ್.
Parts per million ಅಂದ್ರೆ
first year solutions.
This is done. Matide? Okay, we'll ಇದಾಗಿದೆ.
ಹೌದಾ ಯಾವ್ದು ಕೇಳಿ ಮಾತಾಡ್ತೀನಿ ವಾಯ್ಸ್ ಕೆಲಸ ಕೇಳಮ್ಮ ಹೇಳ್ತಾರ ಅವ್ರು ಮಾಡ್ತಾರೆ. ಕಮ್ಯುನಿಕೇಟ್ ಮಾಡ್ತಾರೆ ಆಗುತ್ತೆ.
ಓಕೆ, ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ ನೋಡ್ರಿ. So 25 ml. So this is a problem based on molarity. Okay. So 25 ml of solution of barium hydroxide on titration with 0.1 molar solution of hydrochloric acid. It gave a titer value of 35 ml. What is the molarity of barium hydroxide solution? Okay, so this is a screen ಕಾಣಿಸಕತ್ತಿಲ್ಲ. 1 minute. ಒಂದ್ಸಲ ಇದ್ ಮಾಡ್ತೀನಿ. Stop share.
Eight seven zero 7274 0980. Fast forward 038.
ಈಗ okay. So this problem, it is based on molarity. So 25 ml of solution of barium hydroxide on titration with 0.1 molar solution of hydrochloric acid gave a titer value of 35 ml. Okay, so the molarity of barium hydroxide solution is, so this is a acid base titration. Okay, acid base titration, one solution is acid, another solution is base. Okay, so it is a type of neutralization reaction. So what we have taken here, So what they have given is barium hydroxide. So barium hydroxide is what? BaOH twice. So BaOH twice, that is barium hydroxide, when it reacts with hydrochloric acid. Okay, what it will give with hydrochloric acid? It will give you barium chloride. Okay, it will give you a barium chloride plus 2 water molecule. Then, so what we are going to find, what is given here? 25 ml of barium hydroxide. So what they have told us, molarity, to find the molarity. Okay, how do you calculate molarity? Molarity formula is M1V1 equals to M2V2. Okay, so now barium hydroxide, will write this for barium hydroxide, OH twice, and this is HCl. Now, barium hydroxide, what is the volume of barium hydroxide? 25 ml of solution of barium hydroxide. So this is V1. Okay, on titration with 0.1 molar hydrochloric acid. So 0.1 molar is of hydrochloric acid. So this is M1. Concentration is given as 0.1. So I'll write here 0.1 into this volume is what? It is 25. Okay, then gave a titer value of 35 ml. So hydrochloric acid volume is given as 35 ml. The molarity of barium hydroxide is, so this is M1. So we have to find what? We have to find the M1. What is M1? Okay, now here basicity and acidity. You can see here HCl. So HCl, it is having what? There is no charge. So this is divided by 2. So barium hydroxide on dissociation, you can see there are 2 moles. So this is divided by 2 and this is divided by 1 because there is no coefficient. 1. Here it is 2 divided by 2. Now what we'll do? Just calculate. So this will be M1. Okay, M1 equals to 0.1 into 35 divided by 2. Okay, do that and see what answer you are getting, and into 25. Okay, just see, first you do this 0.1 into 35. Okay, 0.1 into 35 divided by 2. What answer you are getting? Just see first. Solve that. You use a simple calculator. Okay, simple calculators are allowed. So make use of simple calculator for calculating. So 0.1 into 35 will give you 3.5. Okay, 3.5 divided by 2. Divided by 2, this will come to 1.75. Okay, now this is what is happening. Now this is the answer for this. Okay, so here what I'll just I'll put here. So it comes to what? It will come to 1.75. Now 1.75, okay, divided by 25. So what is the answer? Divided by 25. So this will come to 0.07 m. So which is our option? Option C. Understood? Okay, so this is molarity problem. Molarity, whenever molarity is asked, we have to use M1 V1 is equals to M2 V2. Now, what all are given entities that you have to write here? So you have V1. What is V1? So this is the volume of barium hydroxide. Okay, this is what? This is M1. Okay, molarity. Molarity M1, molar. Molar means what? It is a concentration term. So 0.1 molar, it is a concentration term of what? Hydrochloric acid. And what is the volume is 35 ml. What they have asked? They have asked molarity. What is the concentration of 0.1? Okay, that is the molarity of barium hydroxide. So we don't know what is concentration of barium hydroxide. You have to keep it as M1. So keep M1. Whatever are the given quantities, put them and you have to subtract. How 1 and 2 came here? Okay, here you can see barium, there is no any coefficient factor, right? It is 1 only. It is 1. So I'll divide it by 1. Here there are 2 coefficient number, that is 2. So you have to divide it by 2. It is called as acidity of base and basicity of acid. Okay, so that is the number. So you have to divided by such numbers and you will get the answer as 0.07 molar. Okay, so this is in terms of molarity. So we'll solve next one. 6.022 into 10 raised to 20 molecules of urea are present in 100 ml of its solution, the concentration of solution is, okay. So there are four options: A 0.02 molar, B 0.01 molar, C 0.001 molar, D 0.14 molar. Okay, so what is the answer? How we are going to solve this? What is 1 mole? What is 1 mole? 1 mole, 1 mole is equals to Avogadro's number, right? Avogadro's number is what? 6.022 into 10 raised to 23. Okay, so 1 mole of urea means what? 1 mole of urea means it consists of Avogadro's number. Okay, 1 mole of urea, it consists of 6.022 into 10 raised to 23 atoms. Okay, 23 atoms. So how much it will be? So now you have to find what they have asked: number of moles present in 100 ml of its solution. So I'll write what? So I'll write here. I'll write it properly here. So number, I'll write it. 1 mole of urea is equals to 6.022 into 10 raised to 23. Okay, then number of moles of urea, okay, number of moles of urea in 6.022 into 10 raised to 23 is how much? Okay, so there into 10 is number of moles in urea is how much? It is 6.022 into 10 raised to 20. It is given here. Okay, now how we are going to solve this? They have told to find the number of moles in 100 ml of its solution. The concentration of the solution will be. So number of moles of urea in 6.022 into 10 raised to 20 is how much? You have to divide it. How it will be? 6.022 into 10 raised to 20. Okay, cross multiplication divided by 6.022 into 10 raised to 23. So what the answer will be? It will be 0.001 mole. Okay, 0.001 mole. How do you find now? Next is what they have asked. These are the number of moles present now. Okay, now we have to find the concentration. How is concentration given as? Concentration is equals to number of moles. Okay, number, what is concentration? Concentration, we write it as number of moles of solute. Okay, number of moles of solute divided by, okay, volume of solution in liters. Okay, volume of solution in liters. So this is the formula. What is the formula? Number of moles of solute divided by volume of solution in liters. Now what is number of moles of solute? This is 0.01, 0.001. So this 0.001 you can write it as 10 raised to minus 3 also, because if you shift this decimal to right, okay, it will be minus. So you can write it as 10 by, it is shifting by 3 points, right? So it will be 10 raised to minus 3 divided by volume of solution is how much? 100, right? They have given it as 100. So I'll write this as only one. Okay, you don't write both. It is either you can write 0.001 or 10 raised to minus 3. So I'll write it as 10 raised to minus 3. This is the number of moles of solute. This is number of moles of solute. Okay, then what is volume of solution? 100. Okay, so this is in ml. So you have to divide it by or you can multiply it by 10 raised to minus 3. So what the answer will be? This will come to 10 raised to, so this 10 raised to minus 3, 10 raised to minus 3 will get cancelled, and it will be 100 is nothing but 10 raised to minus 2 mole, or it is 0.0, okay, 0.02. So it will be 0.01, right? 10 raised to minus. So this will be 0.01. So it will be B. Okay, so like this, you have to write the answer. So they have asked what? 6.022 into 10 raised to 20 molecules of urea are present in 100 ml of its solution. the concentration of solution is. What is the concentration of solution? So like this, you have to solve it. So 10 raised to minus 2 is nothing but you can shift the decimal to here. Okay, by right hand side, then it will come 0.01. So our option B is the right answer. Okay. Next question of a 5.2 molar aqueous solution of methyl alcohol is supplied. What is the mole fraction of methyl alcohol in solution? What is mole fraction? We are given what is mole fraction. So mole fraction is expressed as psi. So mole fraction, if you want to find the component A, it is the number of moles of component A upon total number of components of A plus B. Right? So this is the way you're going to solve it. Okay. So this is mole fraction. So how do you calculate mole fraction? Number of moles of A. Okay, number of moles of A upon total number of moles of A plus B. That is number of moles of solute divided by total moles of solute plus solvent. That is total moles in solution. Okay, this is mole fraction. Now what they have given, it is 5.2. Okay, 5.2. So this is number of moles of what? A 5.2 molar aqueous solution of methyl alcohol. So this is how I will write it. Just see. I hope you are writing down now. Right? Whatever I'm solving, please note it down. It will be very important. Like this only questions will come. Okay. So number of moles of methanol, what they are given, numbers of moles of methanol, it is given as N2. It is 5.2. Okay, it is given as what? It is 5.2. So number of moles is given as 5.2. Now aqueous solution. What is aqueous solution? So what is the solvent used here? It is water. So methanol, okay, methyl alcohol is prepared in water. So what is the number of moles of water now? So number of moles of water. How do you calculate number of moles of water? You know how to calculate number of moles. So remember this, number of moles can be calculated as given weight upon molecular weight. Okay, so this is the formula, molecular given weight upon molecular weight. What is given weight of water? What is water given weight? It is in 1 liter, right? So 1 liter means 1000 ml. So 1000 divided by what is the molecular weight of H2O? So water is 60, hydrogen is 2 plus oxygen is 16. So it will be 18. So 1000 divided by 18, it will be 55.5. Okay, so this is the number of moles of water. Now what they have asked? They have asked the mole fraction of methyl alcohol. So next step is what? Mole fraction of methanol. Mole fraction of methanol is equals to N2 plus N1 plus N2. So this is the formula of mole fraction. Okay, how do you calculate methanol mole fraction? That is N2 okay, so it will be N2 divided by N1 plus N2. Okay, that is N2 divided by N1 plus N2. What is N2? N2, what is the value of N2? It is 5.2 divided by what is N1? N1 is 55.5 plus what is N1? N2 will be 5.2. Okay, so just see what answer you are getting. 5 plus 2 divided by, so it will be 50. So 55.5 plus 5 plus 2. Okay, what the answer will be? Just see. So the answer comes to 0.086. Okay, 0.086. 0.086. So option C. Okay, option C is the answer. Understood? Okay, so here what is given? So mole fractions of methanol is given. Okay, mole fraction of methanol is given, that is the number of moles of methanol is given, then you have to find out the number of moles of water. Then how do you calculate mole fraction of methanol? That is number of moles of methanol, that is N2 divided by N1 plus N2, the total moles. Okay, so this will so like this you have to solve. So okay, note down this important formulas. These are very important. Okay, please note them. So it will be very important for you to solve the question. So how do you calculate number of moles? Given weight upon molecular weight. Then mole fraction. How do you calculate mole fraction? Mole fraction. So that is if you want to find the component B, so it will be N2 divided by N plus N2. Okay, N1 plus N2. That is the total number of moles. So like this, you are going to solve. So our option C is the right answer. Okay. Option C is the right answer. So we'll go for the next one. The molarity of a solution obtained by mixing 750 ml of 0.5 molar solution of HCl with 250 ml of 2 molar solution of HCl will be. Okay. So what will be the, so they have given, they have they have told there are two solutions of HCl. Okay. There are two solutions of HCl. You have to find the resultant molarity. Okay. How do you find out? So you know the formula. So the molarity of a solution obtained by mixing. So this is 750 ml of 0.5 molar. Okay, one solution is this and another solution is 250 ml of 2 molar HCl. So both are HCl solutions only, but both concentration is right. Okay, so now we have to find the concentration by mixing. So how it will be? So M3V3 equals to M1 V1 plus M2 V2. Okay, so what is M1? So how do you find out? Now M1, now we have to find what? We have to find the molarity of solution obtained by mixing. So we have to keep here M3, so M1 plus V1 plus M2 plus V2 divided by M3, sorry, divided by V3. Okay, so this is the formula to find out the molarity after mixing the two solution. So this is one solution. Okay, 750 is the volume of one solution, 250 is the volume of next solution. Okay, so concentrations are also different. You have to find the molarity of solution after mixing. So how you will write it now? So I'll write it here. So M1, what is M1? M1 is 0.5. M1 is 0.5. Okay. M1 is 0.5 into what is V1? V1 is 750. 750 plus. What is M2? M2 is 2 into 250. Okay. Divided by. What is V3? How do you get V3? So V3 is equals to V1 plus V2. What is V1? V1 is 750. V2 is 250. So this will come to what? This will come to 1000. Okay, this will come to 1000. So this I'll write. Just see what answer you are getting. Just see. You will get the answer as, okay, it will come to 0.875 molar. Okay, option C. I hope you're getting the answer, option C. Okay, you should get option C as the answer. Okay, so option C. So there are two solutions of same, okay, HCl, two solutions are there. What you have to do? You have to find the resultant. Resultant means what? You have to find the concentration of the solution after mixing. Okay. So this is the way you're going to solve it. So this is a formula. Please note it down. Very important are these formulas. Okay. Similar questions, if they are given, you can use this particular formulas and you can solve them. So you have to just put the given quantities and you have to find out the answer. Okay, so simple calculation, simple solving, and you will get the answer. Okay, so we'll go for the next one. When the concentration is expressed as the number of moles of solute per kilogram of the solvent, then it is called as. So this is a formula. So we have seen concentration terms. So when you write number of moles of solute, divided by that is dissolved in per kg solvent, okay, per kg solvent, then it is what? This is the formula, or this is the concentration is expressed for which term? It is used for molality. Okay, molality is nothing but number of moles of solute divided by per kg of solvent. So it is B. What is molarity? Molarity is number of moles of solute divided by the total volume of solution in liters. Okay, here it will be liters, not kg. Okay, it will be this volume of solution in liters. So this is wrong. Molarity. Normality is what? Normality is gram equivalent weight divided by the volume taken in 1 liter. So this is also wrong. What is mole fraction? Mole fraction is total number of moles of solute divided by, sorry, number of moles of solute divided by total number of moles of solute plus solvent. Okay, so this will be your mole fraction. So this is the mole fraction. So this is mole fraction formula. So this is also wrong. So molality. Molality is what? Number of moles of solute divided by per kg of solvent. Okay. So option B is the right answer. I hope this is clear. Okay. So we'll go for the next one. This we have solved. Okay. So next concept is Henry's law. So Henry's law is very important concept. So what does Henry's law states? Henry's law states that the partial pressure of the gas in vapor phase is proportional to the mole fraction of a gas in the solution. Okay, so partial pressure of the gas in vapor phase is proportional to the mole fraction of a gas in the solution. So whenever you are comparing the partial pressure of a gas, okay, is what? It is proportional to mole fraction of gas. So this is the statement given by Henry, okay, in his law. So mathematically, how do you express? So partial pressure is given as small p. So this pressure is directly proportional to mole fraction. Okay, the mole fraction is represented as psi. So when you remove this proportionality sign, okay, when you remove this proportionality sign, then you need to introduce a constant, that is Henry's constant. So Henry's constant is given as Kh. So what is Kh? Kh is Henry's law constant. And what is this psi? Psi is nothing but mole fraction of a gas in the solution. Then remember that higher the value of Kh, okay, higher the Henry's law constant. If the value of Henry's law constant is higher at a given pressure, the lower is the solubility of the gas. Okay, so it is inversely proportional. So if Henry's constant, that is if Kh is higher, if the value of Kh is higher at a given pressure, what will happen? The solubility of a gas in the liquid is lower, or it is vice versa. If the value of Kh is lower, what will happen to the solubility of a gas? Then the solubility of a gas in the liquid will be higher. So it is inversely proportional. It is inversely proportional. Okay, remember this statement, very important. Okay, so what is Henry's law? Partial pressure of a gas in a vapor phase is directly proportional to the mole fraction of the gas. Okay, so this is a mathematical expression given by Henry. Understood? So based on Henry's law, we are going to solve some problems. So remember this statement. Okay, remember this statement. Please make please note it down. Okay, make notes. So write this point as well as this particular statement. Okay, so this is Henry's law. So based on Henry's law, this is the mathematical expression. So partial pressure is equal to kh into psi. Why we are introducing this? Because partial pressure is directly proportional to psi. So when we remove this proportionality sign, this is proportionality sign. So if you want to remove this proportionality sign, we need to introduce a constant. And here we have introduced a constant called as Henry's law constant. Okay. So we'll go for the next. So next is another law called as Raoult's law. So what does Raoult's law state? So Raoult's law states that for a solution of volatile liquid, the partial vapor pressure of each component in the solution is directly proportional to its mole fraction. Okay. So for a solution of volatile liquids, the partial vapor pressure of each component is what is happening is directly proportional to its mole fraction. So according to Raoult's law, okay, Raoult's law, P1 is equals to P1 naught into psi 1. Oh, okay, so the partial pressures are directly proportional to its mole fraction. So this is for component 1, the statement will be like this, and for component 2, the statement will be like this. That is P2 is equals to P2 naught into psi 2. Okay. So partial vapor pressure for each component in the solution will be directly proportional to its mole fraction. So this is the statement given by Raoult. Okay. So this was the statement given by Raoult. So this was formulated as Raoult's law. Okay. So here, what are these P1 and P2? P1 and P2 are called as the partial vapor pressures of the two components, that is of 1 and 2 component. And P1 naught and P2 naughts are the vapor pressure in pure state. Okay. And psi 1 and psi 2, these are called as what? These are the mole fractions of two components. Then how do you calculate the total vapor pressure? So whenever you want to calculate the total vapor pressure, then you have to add the sum of all the partial pressures. Okay. You have to add the sum of all the partial pressures. So how do you find the total vapor pressure? That is P total is equals to P1 plus P2. That is sum of all the partial pressures. Okay. So this is important. Note this also down. So total vapor pressure will be equal to sum of all the partial pressures. That is P total is equals to P1 plus P2. Okay. So based on this particular equations, we are going to solve some problems. Then what is ideal solution and what is non-ideal solution? Ideal solutions are those which obeys Raoult's law. Okay. And what are non-ideal solutions? Non-ideal solutions are those which do not obey Raoult's law. Okay. So ideal solution, how is the mathematical expression? It is given as P1 is equals to psi 1 into P1 naught, and P2 is equals to psi 2 into P2 naught. So these are the mathematical expression for component 1 and 2. In non-ideal solutions, P1, that is partial vapor pressure, is not equal to psi 1 into P1 naught. Okay, P1 naught is called as pure component. It is a vapor pressure of pure component. P2 is not equal to psi 2 into P2 naught. Okay, then ideal solution, delta enthalpy mix. Okay, that is delta enthalpy mix will be equal to 0 and delta volume mixing will be equal to 0. In non-ideal solution, delta enthalpy mixing will not equal to 0 and delta volume mixing will be not equal to 0. Then when you're talking about AA interactions and BB interactions, they will be equal to AB interactions in ideal solution. Okay, whenever you're talking about the interactions between the solute solvent, okay, solute and solvent interactions will be equal to solute solvent interactions in ideal solution. When you're talking about non-ideal solution, solute interactions and solvent interactions are not equal to solute solvent interactions. Okay, so because of this reason, delta V mix and delta H mix will be not equal to 0. So upon mixing, there will be some change in the volume, okay, and change in the enthalpy. So it is not equal to 0. Then ideal solution, they do not form azeotropes. Okay, so they in ideal solutions they do not form azeotropes. In non-ideal solutions, they form azeotropes. So these are some of the important differences between ideal solutions and non-ideal solutions. So we'll solve one questions based on Henry's laws constant and we will stop the session. Okay. So the question is H2S is a toxic gas. H2S is a toxic gas used in qualitative analysis if solubility, okay, if solubility of H2S in water at STP is 0.195 m, what is the value of KH? So this is the question given. So we have to calculate what? We have to calculate the Henry's constant. So we have seen the equation. What was the equation given as? P is equals to KH into psi. Okay. So what is given here? The solubility of H2S is water is given. Okay. That is 0.15 N. Now, what is psi? Psi, we know that psi is number of components of A upon Na plus Nb. Okay. Number of moles of components of A and B. Okay. Now H2S in water. What is given here? H2S in water. So H2S in water, what is given? The molality is given. Molality. What is molality? Molality is number of moles of solute dissolved in per kg of solvent. So that is 0.195 m. Always small n represents molality and capital M represent molarity. Okay. Then how do you calculate molality? Molality is equals to number of moles of solute divided by mass of solvent in kg. Okay, in kg. Now what is the mass of solvent? H2S in water. So solvent is the water, so it will be 1000. Okay, so the mass of so I'll write here. So mass of water. So water is the solvent. It will be what? It will be 1 kg. 1 kg. Okay, that is 1000 grams. Right? 1 kg is equals to 1000 grams. Now, how do you find? Now, molality is given. Number of moles. We have to find out mass of the solvent. We know, right? What all we know in the formula? Molality we know. Mass of the solvent we know. We don't know number of moles. So, how do you write? Number of moles is equals to molality into mass of solvent. Okay, mass of solvent. So this is the formula. Just cross multiply. What is unknown we have to write there. So what it will be? What is molality? Molality is 0.195. What is mass of solvent? It will be 1. So number of moles will be 0.195. Okay, 195 moles. This is 1 kg. Okay, I have taken it as 1 kg. So it will be 0.195 moles. Now, molar mass. Next, we have to find what? We have to find the molar mass because we need to find the mole fraction of this. So molar mass, how do you find the molar mass of water? Molar mass will be equal to, now molar mass of water is 18. Okay, so number of moles of water. Number of moles of water, how it will be? Given weight upon molecular weight. Okay, given weight is what? Given weight is 1000. What is molecular weight is 80. Given weight is here, see, 1000. So 1000 divided by 18, it will be 55.5. So this is the number of moles of water. Now we will use this formula. Okay, this formula we will use. I'll write the, okay, this formula. What is Na? Na is number of moles of H2S upon, okay, number of moles of H2S plus water. Okay, now what is number of moles of H2S? Number of moles of H2S we have found out here. It will be 0.195. Okay, here it is the number of moles of H2S, right? Number of moles of H2S is what? It is 0.195 divided by number of moles of H2S is 0.195 plus number of moles of water is 55.5. Okay, 55.5. What will be the answer? This will come to 0.0035. So this is mole fraction. Now what we have to find? We got now mole fraction. Okay. Then we want to find this, what pressure, standard pressure we know it is 0.987 and we have to find the KH. So use this formula, pressure is equals to KH into psi. What is KH? We don't know KH. So this will be partial pressure upon psi. What is partial pressure? Partial pressure is given as 0.987. This is given. Okay, standard. Standard pressure at STP, the pressure will be 0.987, and what is the psi, that is mole fraction is here 0.0035. Okay, so after solving, just see simple calculation, 0.987 divided by 0.0035, it will be 282 bar. So our option D is the right answer. Okay, so like this you have to solve. Understood? So these are the question based on Henry's constant. Okay, this is a question based on Henry's constant. So first you have to find what? First you have to find the number of moles of H2S. Okay, we have found out the number of moles of H2S. Then what we will do? We will find out the number of moles of water. Then we will add it in the formula of mole fraction. Then we are going to use that in the Henry's constant. Okay, to find the Henry's constant, the value of Henry's constant. This is the formula we have to use. Okay, so from the next class, you see that you take a simple calculator. You take a simple calculator for exam, for CET exam, for your annual exam, you are allowed with simple calculator. So you can do calculations using simple calculator. It will be more easier. And whatever important formulas I'm writing, whatever I'm solving, please write it down. Okay, please write it down. It will be very important. Similar questions will be asked in the exam. So make sure that you note it down. Don't just look at the answers, what I'm solving. Please make a note of it also. It is very important, so that it will be very easier for you also to revise. Okay, next class, again, I will revise this once more. This question, just you can make the note of this particular answer, whatever I have solved. So next class, I will solve it again. Okay. So I'll stop the class here, so we can continue the remaining part in the next class. So this particular question, again, once I will solve it, and then we will continue with the problems based on Henry's law, then Raoult's law. Okay. So thank you. We will stop the session here. Okay.